Myself Sahu, lecturer in electrical engineering. In today's class, we will discuss electrolytic process. In that, we will go for electrodeposition and important terms associated with electrodeposition or electrolysis. And then we will go for further possible electrolysis process. And lastly, we will solve a simple numerical problems which is based on electrodeposition or you can say Furnace loss of electrolysis process. So what is electrodeposition? Before that, what is electrolyte? So electrolyte means if we pass an electric current through a substance, if that substance gets dissolved or decomposes, then we call is as electrolyte. So the definition for electrodeposition means by the process of electrolyte process, suppose let us take this a metal A, then we will, if we do some process by layering another metal over a other metal, then we will call as electrodeposition. So electrodeposition is the process by means of electrolysis process. Then suppose let us take an example. I have taken copper as a material, then there is a iron ring. What we will do is, over a iron ring will coated the copper. So the process involved in this, over a single metal, then we will go for other metal layering, then that is called as electrodeposition. So electrodeposition having some important terms, we will discuss those terms first, then we will go for further discussion of electrolysis. So in this electrolyte process or electrodeposition, two electrodes are there. The positive electrodes of the battery which is connected to positive supply, then that is called anode. And the negative part which we have taken here example as iron ring, that is your cathode. So the important terms which are associated with this process are first electrolyte. So what is electrolyte? So the metal rods or plates that are connected to the supply, that is called electrolyte. That is called electrode. And electrolyte means the solution. Here we have taken CuSO4. That solution is called, generally that solution can be solids or liquid. Generally that liquid is also salt. Here we have taken CuSO4. That liquid which is dissolved is called electrolyte. Electrolyte. Anode, what is anode? The positive part is called the anode and the negative rod or negative plate is called cathode. In this example, we have taken a copper bar and an iron ring. Our aim is to coat this iron ring with a copper layer over it. So in this process, supply positive to the anode and negative to the iron ring. When we supply the battery, then the process we have taken the electrolyte as CuSO4. Then that CuSO4 will be part into two parts, which is Cu plus and SO minus. SO minus two ions, two ions, one is two positive ions and the other part is the negative ions. This CuSO4 will be converted into, or you can say dissolved into two parts, Cu plus and SO minus. That is positive and negative ions. This positive anode which is copper, this Cu and this negative part SO4 minus and Cu plus is the positive part. So the positive part will be attract to cathode Cu and the negative part will be attract to the positive part which is copper. Then this negative part SO4 minus will be attract to becomes CuSO4. While this positive part, that Cu plus will go to the iron ring, then eventually a copper layer will be formed over the iron ring. So this is the process of electrolysis. Then we go for Faraday's laws of electrolysis. So Faraday's laws of electrolysis is very important law where we can see that the amount of deposition which takes place in the electrolysis process can be found out easily by the first law of Faraday's law. Faraday's having two laws, one is your first law and second law. First law says that whenever we supply an electric current through a electrolysis process, then there will be some amount of electrode deposition. So the amount of electrode deposition is depends on the amount of current we are flowing through that metal and the time which is associated with that process. So that amount of substance, let us take it as W. So W is proportional to the Q. Q is the amount of charge. So as we know that the definition from the current means the rate of flow of charge, that is dQ upon dt, that the rate of flow of charge is called electric current. So from this we can write down like this: I equal to Q upon T. So Q equal to IT. Q equal to IT. So we can use this result here: W proportional to Q, and or we can write down like this: W is proportional to, instead of Q we can replace Q equal to I into T. I into T. So as we know that in any mathematical proportional equation we can equate with a constant. Here the constant is W equal to ZIT. This Z is the proportional constant here known as EC, that is electrochemical equivalent of the process. W equal to ZIT. So in our numerical problem we can easily solve this. And the second law says that if we supply the same amount of current through a different substance, then that different substance having the amount of liberated weights that can be given by the proportional of its equivalent electrochemical equivalent, that is proportional to the equivalent Z. Now we will solve a simple numericals to understand it better. So here we have taken a simple example. If a current of 10 ampere deposits, if a current that is flowing 10 ampere, it deposits 30.42 grams of silver solution in 20 minutes. Calculate the electrochemical equivalent of silver. Here the current is given as I equal to 10 ampere and the amount of electrode deposition will be given as 13.42 grams. So the amount of electrode deposition W equal to 13.42 grams. The current I equal to 10 ampere and time is given here is 20 minutes. So T equal to 20 minutes. So we have to convert this minutes into seconds. So this is equal to 20 into 60 to 1200 seconds. 1200 seconds. So from the Faraday's first law, we have seen that W, which was proportional to Q, or W is proportional to IT, and W equal to ZIT. Here this Z is called electrochemical equivalent or ECE. In our question, it is asked to calculate the electrochemical equivalent of silver. that is we have to find Z. So W equal to Z into IT. Here the W is already given 13.42 gram. So 13.42 is equal to Z into I into T. So Z equal to, we can directly write down Z from this equation. Z equal to W by IT. So by using this, Z equal to W by IT. W by IT. W is 13.42. So 13.42 divided by correct 10 into time 1200. So this will come from 0.00118 gram. So it is 0.0018 gram for Coulomb charge. Thank you.